So now, when it comes to Zener diodes, they build up a voltage across them once current's flowing through them. Now it does vary a bit based on how much current is flowing through them. So 1 milliamp is probably not the best amount of current to use, but at some point you'll find the perfect amount of current to get 5.1 volts across the Zener diode. This is not meant to provide power. Anything you try to power will steal the current and it'll throw off that Zener diode. You want the current to flow through it. This is a reference voltage for other circuitry to look at and respond to in some way. But the main takeaway is, as long as you have a current source or a current sink, then that will set current with everything in series with it right there, even as the supply voltage changes. So the Zener diode will not vary with supply voltage like it will with a resistor. The amount of current flowing through the resistor, it'll be the supply voltage minus the Zener voltage right there. But if you make it twice as high, twice as much current's going to flow through. And the Zener diode will still be close to 5.1 volts in this particular case right there, but it will drift a bit, which you may want to eliminate, and therefore doing so with a current source. So now, in the last video, I shot for 1 milliamp of current through a JFET right there, wired as a current source. So as long as we stay below its IDSS, which I believe is 33 volts for this particular one, because it varies even with the same part number. As long as you stay below that, you can set any current you want based on how much resistance you got between source and gate. And then they both head to ground. Load can either be on the low side of that would make it a current source, or it could be up on the high side right there. That would make it a current sink. That's the opposite, or that's the difference between the two. But whenever you got a current sink, if the load was up here, you can still call it a current source because it's setting through the current through everything that's in series. So just be aware of that. But in any case, again, doesn't matter on the supply voltage as long as you have enough voltage to meet the needs right there. I think it's about 3 volts, plus whatever the load needs. So now, I already have the meter set to measure milliamps of current, and then we'll see we got pretty close to spot on 1 milliamp of current flowing through there. You got to put the current through the meter. Again, it's everything that's in series. And we got 8 volts there. I think I wrote like 20 volts or whatever on the other sheet. But in any case, we can change the voltage and we will get the same amount of current right there. So that is a lot more voltage, but current stayed the same. Now we'll add an LED in series right there, green LED, and you can see that we got about 1 milliamp of current with the green LED. So this is similar to the Zener diode right there, but the green LED is going to drop, about 3 volts across it instead of the Zener diode right there. But same basic effect right there. We're maintaining 1 milliamp of current regardless of voltage change or load change, as long as we got enough voltage to power everything. So now we're going to measure voltage. We added the Zener diode there between our 1 milliamp current source, because it doesn't matter where it's coming from, as long as it sets 1 milliamp, and to ground right there, because we need to have the current flowing through it while the voltage is applied. And it's actually higher than I thought it would be. But 5.1 volt Zener diodes are pretty good at staying close to 5.1 volt, as long as you got current flowing through it. And now we will come over to the power supply. So again, we already saw this does not change how much current is flowing through the circuit right there. It's not even seeing current flowing, because this is not as accurate as a multimeter right there. That should say about 1 right there. So if you're wondering the wattage, if there was just one component, we got 20 volts, 0.001 amps of current. That would be, since it's multiplied together, 0.02 watts of power. And the quarter watt resistor by itself is rated for 0.25 watts. You should stay below 0.125 watts. But again, this is still much lower than that. So we're really safe. We got multiple components splitting up the voltage, and thus they're all helping to dissipate the power. But the main takeaway is we got that same voltage right there, 5.163. And things might shift a little bit as they warm up or whatever. That is to be expected. But our reference voltage there is pretty rock solid, because we set a current going through the Zener diode. In this case, we used the J310. It's a JFET. JFETs are good for making current sources. as long as you stay below the maximum current they can provide. If we put the source and the gate directly together, instead of having resistance right there, then it will pass the maximum current that this particular component will pass. So the J310, it's like between 20 and I believe 60 milliamps of current you can expect from one of these components. You actually have to test it, see how much it provides. And I believe this one provided about 33 milliamps of current or whatever. But that doesn't really matter as long as you stay well below it. 1 milliamp of current is well below what this one can provide. There's other JFETs that I think would struggle even with 1 milliamp of current. So you got to make sure you check the data sheet for them. The main takeaway was that a steady current will get you a steady voltage. So now we'll look at using a resistor instead, which sets a current, but it will depend on the supply voltage and the Zener voltage. So now this is a 4,700 ohm resistor setting the current through the Zener diode based on the supply voltage minus the Zener voltage there, 5.138. And now we'll move it over. You can see the power supply still does not show any current flowing. I believe it will when we go up to 20 volts. So there you can see it quite significantly raised how much current is going through. Maybe like 3 times as much or something like that. In any case, main thing is we definitely have a lot more current flowing through. This should be a fair amount higher than it was before. So I believe it was 5.16 again, I believe, or whatever. And there you can see 5.187. So again, this one is not as dramatic as different values. The 5.1 and the 5.6 volt Zener diodes tend to be more steady as the current changes than higher value Zener diodes or lower value Zener diodes. But that is the main takeaway. So we can actually just kind of do a quick view of the differences. So we got 5.189 when I get a good press on them right there. Drop to 10, and you can see it's shifted a bit. So again, this is not dramatic. As I said before, the 5.1 volt Zener diodes tend to be pretty stable, even as current changes a fair amount. But we did have change there, which if you had a circuit that really depends on a specific voltage staying steady, even as you get like supply bumps or whatever, you know, because you could add a capacitor to also maintain this for a short period of time, then you know, the current source is the better way to go for that steady Zener voltage if you're wiring something up like that. There's also components that are good at setting a voltage, reference voltage, and I can't think of their names off the top of my head. But in any case, Zener diode is a basic component that you should learn about, even if you don't use them in your circuits. You use more sophisticated components, and the basic properties are still good to know about. So, in any case, that's really about it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.